4, 3, 2, 1.
All right. Welcome to this month's SLC.NET meetup. It's March 2021. Let's get started. Here's the agenda. Quick intro, telling you about the schedule. That's right now. So we're going to have lightning talks, which is a chance for people to speak for 0 to 5 minutes about a topic that would be of interest to the group. And we could have 0 to 3 of those probably. And then the main presentation, Modernizing an Existing System to Take a Domain-Driven Approach, presented by Bill Penberthy, who's joining us from Seattle area. And then after the presentation, last time we talked about the possibility of doing a book club kind of thing. So, and some people expressed interest. So we can talk about that. For those that are interested, stick around and we'll talk about the book club. We've got YouTube channel. If you want to, and this is being streamed to YouTube right now. If you want to ask questions here in Zoom or on YouTube, we will do our best to answer them or ask them to Bill. All right, it's time for some lightning talks. Does anybody have a topic they'd like to talk about? Can people see my shared screen?
I can.
You can? I also can.
Okay, because I got a message that someone could not. Okay. Still on lightning talks. Anybody? Will, when he talks about this portion, he likes to make people wait. So we'll wait a little bit longer.
Sure, blame it on Will.
Yep. He did it first. I'm just copying him.
I'm good to be blamed. I'm all for it. In fact, I encourage it.
So I can give one.
All right. Awesome. Go ahead. I will start a timer to let you know when your time is up.
Okay. So I didn't think about this at all. Hopefully you can see me. I can't see myself, so that's all right. So lately I've had the opportunity to working in Azure a lot more. And one of the areas that I've needed to quickly become familiar with is Azure Log Analytics, which is the backend for Azure Application Insights. And it took me a while to realize that all of the queries I was writing, so as a little bit of background, so Azure Log Analytics uses Kusto as a query language, which is a language they created that allows you to write queries against it. And those queries can kind of like MapReduce, right? They can span multiple, service instances and other things so that you can get data from lots of different sources, right? So think about this as a way of querying big data. So it's not exactly Hadoop or anything, but a lot of the same concepts are there. So having come from a SQL background, I was working under the assumption that, hey, when I do a select count or a select decount, which is distinct count, I'm actually getting back, the count of records. So it's like, hey, these queries run pretty quickly and all of that, which is great. I was happy with the results. And then later, as I started going through documentation, right, because who reads documentation first, I started finding that the results weren't exactly what I expected. And by what I mean by that is the data is actually in many cases estimates. And there are parameters to the functions like count, decount, or other things that allow you to specify the error level that you want. And that error level is what in turn controls the accuracy or the speed at which the results come back. So by using the defaults, I was getting an error rate of around 1.2%. You could change it by passing in a separate value. So if I remember right, I think the highest for accuracy that you could go using these standard operators was 0.4% accuracy. But I just thought it was fun that here I was using Azure log analytics, writing Kusto queries, and yet the whole time I was being lied to because it was trying to be a little bit more intelligent and say, hey, you have way too much data for us to really do this, but we'll give you something quick that does pretty much what you're looking for. So, and with that, that's my lightning talk. Big data is different. Azure Kusto, log analytics is different. It's not bad, but know that there are definitely things to learn in it that aren't akin to what we find in the SQL world.
All right, thank you, Caleb. Now, if folks want to, this would be a time where you can use the Zoom feature to clap. I don't know.
Or ask questions. We still don't have our 5 minutes in, so.
Sure.
Well, I'd like to. So does it use sampling? How does it?
It does use sampling.
Okay. Does it say what, is that one of the options that you get to choose, is how big of a sample set or how often it samples?
I haven't yet read the full
Okay.
docs. So to be fully honest, I don't know exactly if there's an algorithm or something. All I know is that there's parameters that allow me to select it.
Okay.
There's some other interesting things. Today I learned that there's like a series FIR or an IRR, like impulse response, that give you rolling averages and other things that are built into log analytics. So you don't actually have to write queries for some of the things that you typically would in SQL. So that was also neat.
Cool. Thanks, Caleb.
Yeah, thank you.
We have time for another lightning talk. And this time we won't wait as long for someone to volunteer. But
Oh, go on. Make it awkward, Steve. Come on.
okay. I mean, we can wait until 5:45, which is what the agenda said for the next item, but I don't think we'll wait that long. Anybody interested? Okay. Well, I think it's time to go to the next part of our meeting. So a little bit about Bill. He's got 15 plus years in .NET software development. Dr. Bill, he brings a pragmatic or curmudgeonly approach to software development. And right now he's working with AWS as a .NET developer and helping AWS build a better and more rich .NET developer experience. We've got some sponsors we want to thank. Health Equity, Tech Systems, Dealer Track, O'Reilly, JetBrains. Tonight, later on, we'll have a chance to win a JetBrains or O'Reilly prize. Speaking of those prizes, you'll want to take note of this URL here. Am I in sync with the slides, or did I get ahead of myself?
I think we usually do this one after, so I think we're on to Bill.
Okay, I got you. This slide comes after my bad. We are ready for Bill to give a presentation. I'll stop sharing.
All right. Let me get that set up here. Hopefully you can see my screen.
Yeah.
All right. Let me just move everything around here. All right. Well, welcome to converting a monolithic application to a more domain-driven design. As you mentioned, my name is Bill Penberthy, and I'm a .NET developer advocate at AWS. My question's about Azure. That was not industrial espionage. I just was curious. So as a .NET developer advocate, that means my work focuses on working with .NET developers and helping them understand how to best take advantage of AWS services. We then kind of take that interaction back into our internal teams and work with them to make sure that our tooling and such is kind of designed to help .NET developers experience better when they're working with AWS. So you're probably asking, why is this clown from AWS here talking to me about redesigning .NET applications? And honestly, it's because it's a fun topic, and it also happens to be one of the most commonly asked questions that we get when we talk with customers about their journey into the cloud. The whole, pick up my VMs for my data center here and move them over there is pretty straightforward. However, you start getting away from those kinds of constraints that you have with those big server models. It's a lot less straightforward as to how you're going to get there. And I imagine if you've been a .NET developer for a while, you've seen one of these kind of big server apps, what we call monoliths, a big web application that does a lot of business logic and thing. And we tend to go historically around end tiers and defining the APIs between each one of those tiers. And we worry about the interoperability between those tiers. But that's, they tend to be in memory, and so they're always on that big server. So now with the cloud, though, you can start rolling out like baby containers or microservices to your heart's content. And that kind of changes the way that you think about designing and architecting your systems. And that's why we always seem to get a lot of people that are talking about, or that tell us, it's nice that you've got all this stuff to allow me to, I'm trying to remember our sales words, rapidly and easily scale up and down and only pay for the compute and memory that I use. But how do I get there? And that's what this session is meant to do, is to help get you started in kind of moving from the thought of a big application to an application that's more designed to be individually scalable. So here's the agenda. We're first going to spend some time going over domain-driven design. We'll talk about some of the different technical approaches to doing the refactor, basically refactoring design patterns. After that, we're going to set the stage by kind of talking about our fictional demo company and describe the application that we're going to convert. Then we'll go over how to plan the converting. It's a lot to try to do in 50 minutes, so we'll see how far we can get. So what is domain-driven design? So they've got whole conferences on it and organizations based around it. So it's a pretty complex subject. And my goal is to get it to you in about 6 minutes. So let's see how we do. So what is domain-driven design? I've seen it referred to as a system design approach, which is basically the first bullet over there. It's also referred to as a way of helping to understand priority, really because of its emphasis on building out the most important or core areas first. Lastly, it's also considered a set of patterns for building enterprise applications. In my mind, it's all three. It's a design paradigm that requires a complete as possible understanding of the business's life cycle, and how that applies to the system being managed. So there are 4 concepts that we're going to go over first: domain, model, context, and business or ubiquitous language. So the first is the domain. The domain is a sphere of influence or activity, the subject area that drives the creation or refactoring of the application. Simply put, the domain is basically everything that your company does. This also means that no matter how similar different companies in the same industry are, their domains are probably going to be slightly different. So the next core concept is a model. This is a very simple definition. A model is a set of concepts that will be implemented in the software. This is different from how model oftentimes ends up being defined, which is as a class, especially if you're used to thinking about frameworks like MVC or MVVM, where M equals model and is always represented by a single class. This model is higher level. Instead, these class files, interfaces, all other kinds of constructs like that, all work together to define the model, the set of concepts that we're trying to implement. The next is context. So there's two levels of context. The first, context, simply context, is the setting around which terminology is defined, the domain. Every domain model lives in precisely one context, and a context contains precisely one domain model. The next level of context is the bounded context. A context becomes bounded when it's defined to the level of providing explicit boundaries around a set of models, sometimes called subdomain models. So there can be multiple bounded contexts within a single context, just as there's multiple subdomain models within the overall domain model. Consider a retail sales company. One bounded context could be the e-commerce web system that they use for B2C sales. Another bounded context could be the system that they use to manage their product inventory. A third could be their sales and order processing system. All of these are explicit boundaries around a set of models, and they identify and define the rules to which each of those models must adhere. So these different bounded contexts may need to communicate to each other. The e-commerce system needs to get order information to the sales and order processing system, and the inventory system needs to know that as well because it needs to update availability. So this whole relationship is within the context. So we need to make sure that we use the same terminology across those bounded contexts. We'll talk a little bit more about that. So this same terminology is the business or ubiquitous language. When working in domain-driven design, we want to build a domain model that captures the problem domain of the system being built. And then we're going to express that understanding in code and software artifacts. To help us do that, it's important that the domain experts and developers consciously communicate using the concepts within the model. This means that the domain experts don't describe a new user story in terms of a field on a screen or a menu item. They instead talk about the underlying property or behavior that's required on a domain object. Similarly, developers don't talk about new instance variables of a class or columns in a database table. They instead use the ubiquitous language. And this is critical because if an idea can't be easily expressed using the ubiquitous language, then it indicates a concept that's missing from the domain model. This means the team needs to work together to figure out what that missing concept is. Once this has been established, then the new field on the screen or the new column in the database table follows on from that. It becomes clear what that should look like. The ubiquitous language already describes that relationship. So let's take a look at how some of these relationships work out. On the left, you have the team. I work at Amazon, so we would normally call that a two-pizza team. But these guys are kind of skinny, so I'm not sure about the pizzas. The team is made up of both domain experts, or the business, and the delivery team, which would be developers, DBAs, QAs, PMs, and whatever appropriate roles there are for your company. The team works to create the shared language while working through their domain knowledge. The domain knowledge is distilled into the bounded context and described in terms of the ubiquitous language. Each of the bounded contexts has relationships with other bounded contexts, which are defined around the various subdomains. I haven't really mentioned it before, but this slide shows three different types of subdomains. From the top down, they're supporting subdomain, generic subdomain, and core subdomain. Sorry, everybody's pictures are right in front of that part of the screen. A generic subdomain is something that's generally consistent across many different organizations. A good example of this is authentication and authorization. There's standards in place around this, there's best practices, and you're typically expected to adhere to these kinds of standards. And they're also easily fulfilled through third-party systems. A supporting subdomain is something that you do that's important, but doesn't provide any critical competitive advantages. A platform to manage geographies like postal codes or things like that could be an example. Another one that we see pretty common is is a system that manages like email or communication templates. These systems are rarely ever complex and are sometimes very rudimentary. And enhancements like adding a WYSIWYG editor to the email templating system tends to be very low priority. The last subdomain is the core subdomain, which are the important things that your business does. These tend to be complex, as most of the intricacies of your business are captured in the rules within these subdomains. So here's where the majority of your work will be done. And as we go through the rest of the session, we'll really be talking about core subdomains. So now that you know some of the words, and it took a little bit longer than 6 minutes, but let's look at some of the common implementation approaches that are recommended as part of domain-driven design. So these are some of the implementation recommendations that we'll touch. Microservices, messaging, eventual consistency, command query responsibility segregation or CQRS, and event sourcing. So I really wasn't able to find a single definition that really explained microservices very well. There is instead a set of what I'd like to think of as defining characteristics, some of which are listed on the slide. It's like microservices process communications over a network using agnostic protocols such as HTTP. An important one is they're generally organized around business capabilities. And microservices tend to be smaller and more limited in scope, messaging enabled, part of a bounded context, independently deployed, and we'll touch on that again, and responsible for its own data, and we'll talk about that as well. So a microservice is not a layer within a monolithic application, example like a web controller or backend for front end, depending on your paradigm. Rather, it's really a self-contained piece of business with clear interfaces and may, through its own internal components, implement what we consider an N-tier or a layered architecture. And it's important to remember that domain-driven design does not require microservices. You could build an application that could be called monolithic or big server, the word that I used earlier, through the use of domain-driven design practices. However, microservices provide a relatively easy way to ensure that the bounded context stay distinct. Crossing those boundaries when using microservices, it requires a much greater intent than would be necessary if you were simply doing like an in-process namespace difference. And I want to go into more detail about the responsible for its own data, because this is one of the areas that I actually had the most difficult really buying into. I was a SQL Server guy. Normalization serves a purpose. Allowing a microservice to be responsible for the data that it cares about was okay, until you realize that some other bounded context may care about some of that data as well, and that they may both be storing that same data separately in even different data designs, because they each care about different parts of the data, and not even in the same database, and not even just different databases like you could do in SQL Server, but perhaps one of them's in NoSQL while the other one's in a relational database. But I kind of came around to the concept of owning their own data, and we'll talk about this a little bit more when we go into depth on eventual consistency. So the next subject we're going to talk about is messaging. Messaging is a system, an architectural approach that allows for communications between multiple interested parties. There are many different examples of messaging platforms. There's RabbitMQ, Apache Kafka, or one of the various AWS products. Azure's probably got one or two too.
Bill.
Yeah.
We have a question about DDD in the chat. Let me read that to you.
Okay. Yeah, I don't see the chat. Okay.
It's hiding in the Zoom interface somewhere. The question is DDD a way to be inclusive, non-technical, and is it related to domain model design pattern?
Is DDD meant to be non-technical? I would say that's, boy, that's an interesting, I think at its heart, DDD is not technical. It is instead a way to define what the system's interoperability will be and how they set boundaries and communicate between each other. I think it's really understanding the rules around that And then the way that you implement them are boundless as well. So I kind of look at DDD as really being an approach that you would do as you design and architect out your system. Not necessarily, some parts of it lend to implementation. Messaging is obviously one of them. Things like that lead to it, but the different messaging patterns and things like that you would use, they tend to be outside of the scope of what I look at as DDD.
Okay, and there was a follow-up. Does DDD care about the physical model at all, or is it only related to the conceptual layer?
Well, that's a very interesting question. So at its heart, I would say DDD does care about the layer, or about the physical model. And it's how you define the model. Because as we go through it, and what you'll see is that we'll end up, especially in something like a monolithic application, you have to figure out what parts of the model belong to what part of the business. Because typically, an approach really seems to be more around an object. So here's all of the work that's going to happen with the product. Depending upon what part of the business that's supporting, here's all the stuff that's going to happen for a product. And this is and DDD is a way to break that up and really not be worried about the object that you're working with, but the business part that you're trying to solve. Did that answer the question, I hope?
There was one other thing they added. They said physical model is tables, in my understanding.
So as you build down through your domain-driven design, you will have an understanding about what data needs to be stored with what service. Now, how you implement that is obviously something that you can choose. You can separate each one of those into their own databases, their own database tables, whatever makes the most sense for the approach and the kind of resiliency that you want. DDD will help you understand what the boundaries are around that data, but it's not really going to give you any direction on how to store it.
Awesome. I think that answers the question.
Okay.
Thank you.
Yeah. And thanks for calling it out. As I say, I still haven't figured out how to see the panel here. Oh, wait, there we go. Now, do you guys see it too? Okay, now I can see it. Thank you.
Cool. And I don't see it on your screen.
Okay, perfect. Only have so much screen space here. Let's see. Where were we messaging? Okay. Yeah. So messaging, you can look at this as a system and architectural approach that allows for communications between multiple interested parties. There are many different examples. Gosh, it feels like I've already gone through all of this. Yeah. He threw me all off now. So let's just go into the bullets. So messaging system decouples providers from consumers. So this means that a consumer doesn't have to know where to go to find the information that they need. They just need to be able to recognize that information as it goes by. The second is the use of horizontal scaling. So if the machines that are handling messages are being overworked, you can simply add more. Platform and language integration, there's no need for the message sender and the message receiver to be written in the same language or running on the same operating system. They can be completely and uniquely different. Reliable communications, messaging queue provides reliable communications because it takes a store and forward approach where the message is stored in the queue and then forwarded to all of the subscribed listeners. So messaging is an ideal approach when needing to work with disconnected systems that may or may not always have communications. By using the store and forward approach, it means that regardless of when the system connects to the network, they're able to catch up on all of the messages that they may have missed. And the last is that the messaging system automatically acts as a mediator. So with the mediator pattern, communication between bounded contexts is encapsulated within a mediator object. Those subdomains no longer communicate directly with each other, but instead communicate through the mediator. So this reduces dependencies between communication systems and reduces coupling. With this, if an application becomes disconnected from the others, it need only reconnect to the messaging system, not to all of the other messaging applications. So the next important concept when considering DDD is a reliance on eventual consistency instead of strong consistency. And that's because not every bounded context has to know everything about the models within the other bounded contexts at all times. Instead, they may simply need to eventually know some of the things. So if you look at the time graph on the slide, the column of green dots kind of demonstrate what I mean by strong consistency. That's what a system with a single shared database would have, because all of the data is stored in a single place, and so it becomes available to every other consumer of the data at the same time. Once the save is committed, everyone knows about it. The only lack of consistency is during the milliseconds of that database transaction. Eventual consistency is different. That's the staggered orangish dots. It means that data will be consistent eventually. There'll be some time before all of the other systems understand the data. And the meaning of eventually is something that you consider when you actually design the physical architecture of your system. So eventual consistency important for not only DDD, but in any effort that really expects decoupling. It's because it provides the service, in this case, the most control over itself. The first bullet pretty much tells the whole story. If strong consistency was required, i.e. two bounded contexts needed to know the same information at the same time, that means that either A, one of the bounded contexts has to have enough knowledge about the other so that it can get that information from it, or B, they both access the same data store. Doing that means that changes in one domain, such as to that table though, could impact another domain. So command query responsibility segregation came around because of two driving forces, collaboration and staleness. So collaboration refers to those circumstances where multiple users will be using and modifying the same set of data. And whether or not the intention of the user is actually to collaborate with each other, it's just that coincidentally two people may be accessing the same piece of information at the same time. You know, there's often rules which indicate like which user can perform which kind of modification, and modifications that may have been acceptable in one case may not be acceptable in another. Staleness refers to the fact that in a collaborative environment, once data has been shown to a user, that same data may have been changed by another active. It's stale. Almost any system which makes use of a cache, for example, is serving stale data, but for a good performance reason. If the data we're going to be showing users is stale anyway, is it really necessary to go to the master database and get it from there? So in short, it seems like we're doing an unnecessary amount of work based on the assumption, typically that reusing code that's already been written will be easier than just solving the problem at hand. Instead, let's try a different approach. How about we create an additional data store whose data could be a bit out of sync with the master repository? I mean, the data we're showing is the user stale anyway, so why not reflect it in the data store itself? So for CQRS, command is an action that's taken that adds, edits, or deletes data from the primary data store. A query, on the other hand, pulls out a read-only snapshot of the data in either a primary or secondary store. So this basically shows what that's like. The drawing's simple. The impact is much less simple. This example has the data being provided separately. This makes sense when you're looking at an eventually consistent service that maintains its own version of the data. However, this is more complex when considering a case where the read is happening from within the same bounded context. So this could theoretically mean the same database. And yes, it could be the same database and the same tables, but with different interpretations of the data based upon what the query cares about. So in that case, you would have one model that would be, and one process to handle the save. Then you would have a different, typically more simple model that handles the read, And then you would use those independently of each other based upon what your need is. And so these are some of the benefits to using CQRS. Independent scaling, optimized data schemas, separation of concerns, and simple queries. By separating the two, you allow them to be managed differently. You can scale each one of them differently, use different schemas, like I mentioned. You could denormalize for reads, and that'll give you simpler queries and faster queries. Segregating the read and write sides can result in models that are more maintainable and flexible. Especially since you'll see that most of the complex business logic tends to go into the write model. The read models tend to be relatively simple. There are also some challenges. CQRX is complex, and it may not be necessary. Adding to that, it's important to define CQRS at a bounded context rather than as a domain-wide implementation pattern. Not every bounded context will need CQRS, so allowing each bounded context to manage its own data's read and write rules provides the most flexibility moving forward, allowing it to control its own data. Another challenge is obviously updating schemas and data during a release, especially when the read and write are significantly different. So if you're looking at a project and you're looking at a refactor, consider all of these if you're looking at CQRS for bringing that into your project. So event sourcing. According to Martin Fowler, who is supposed to know some things about this, the fundamental idea of event sourcing is that of ensuring every change to the state of an application is captured in an event object, and that those event objects are themselves stored in the sequence they are applied for the same lifetime as the application state itself. Basically, event sourcing is a process where all changes to application state are stored as a sequence of events. I mean, when you think about it, it sounds like it could be a real stinker, though. A typical application has a lot going on with it. However, if you think about the other concepts that we've already talked about, such as messaging and eventual consistency in CQRS, you'll see that a lot of these events are already being created for each bounded context. So implementation of storing these events long-term is almost trivial because in many ways you're already doing it. So event sourcing provides several layers of information. The first is to be able to identify at any point in time the state of a piece of data. The second is that you have recovery built in, restoring an old, well-known database and then rerunning all of the messages that were played. That puts that data in the database into the proper state. And since it's replaying it, you have the ability to retroactively fix errors. Think about that for a minute. With a traditional design, an error in business logic somewhere can lead to bad data. Say there is a change in an old product service where the request to change the product inventory because of a sale actually resulted in the inventory count being increased rather than decreased. That would be difficult to fix. With event sourcing, though, after you fix the business logic, you can restore the previous database, rerun all of the events for that data, and since the business logic is fixed, the values will all be updated correctly so your data has been repaired, for lack of a better term. And yes, if there's a lot of events, it may take a while, but I can almost guarantee that'll be a lot faster than trying to understand and fix those errors by hand. So there's some requirements that event sourcing does a good job of fulfilling. The first is if you want to capture the intent of the data. An example of this could be changes to a customer entity that are captured as a series of specific event types, such as maybe moved home or closed account or deceased. That kind of intent can be captured along with all of the data changes. Another reason to use event sourcing is if you need to minimize the occurrence of conflicting updates. Event sourcing can help prevent concurrent updates from causing conflicts because it avoids the requirement to directly update objects in the data store. Though, of course, that implies that the domain model must still be designed to protect itself from requests that may result in an inconsistent state. And the next reason, and I think I mentioned it in the last slide, is that if you're already using events within your system, you may need to tweak the events slightly to capture the additional data, as well as perhaps add some additional events that you're not using. But the infrastructure is already there and being used, and the implementation path is much simpler. The last item I tossed on the list was if you want the flexibility to change data format. Changing the message schema is pretty simple, and interpreting the changes can be easier as well. If none of these items are a concern to you, then using event sourcing is likely to add complexity for no gain. And that's one of the problems that I've seen with people that are looking to take a domain-driven design approach, that feel that since they're doing that, they need to use CQRS and they need to use event sourcing, and that's not always true. And I think that goes back to the question that we talked about a little bit earlier about the technical nature of DDD. I think what you're going to find is that by separating the bounded context and separating and setting up eventual consistency, you may find that a lot of the complexity of the original system you had is no longer necessary, because in my experience, I've seen that that's typically seems to be caused by poor boundaries between the concepts. And that could be solved by letting each microservice or each business area, each one of those manage their own data, even through a basically CRUDly approach is fine. And CQRS may not be necessary, or may only be necessary or in one or two extremely complex bounded contexts, and not across the board. So now that we've talked a little bit about what DD is, let's look at a few different refactor patterns that I've used when refactoring applications. So these strategies or refactor design patterns are different ways in which you can change your system in your effort to build a domain-driven design. Now, this is certainly not a complete list, not at all, but they offer different approaches for refactoring systems. Also, these patterns are not exclusive. You'll find as you work through the changes that you'll use many of these, if not all, and sometimes together. These patterns, and you've probably heard of at least one of them, if not all of them, are Strangler Fig, branch by abstraction, and change data capture. So the most well-known of these refactor patterns is the Strangler Fig. Implementing this approach means that you'll create a new system basically running in parallel with your existing system. Over time, you'll move responsibility and functionality from the current system over to the new system. The primary differentiator in the Strangler Fig is that it depends upon a call from outside of the system that will eventually go to the new system. So the idea with the Strangler Fig is you replace the old monolithic system with the new system one piece at a time, just as shown on the image on the screen. As you can see, however, there's one very big requirement for the Strangler Fig pattern to be successful. That's that you have to have the ability to clearly map the inbound functionality that you want to refactor. If your code being migrated is deeper, or there are existing calls coming to it from both inside and outside your application, then Strangler Fig may not be your best approach. Instead, that's where you would evaluate branch by abstraction. This is very similar to the Strangler Fig pattern. However, the Strangler Fig pattern depends upon external calls coming into the system, while the branch by abstraction approach works completely within your system and does not require any changes to systems outside the one application being refactored. No, many people combine both of these architectural approaches and call it Strangler pattern, or sometimes a Strangler Fig pattern. But I'm a purist, and I think that they're uniquely different approaches to solving complex refactorings. Is that a word? Refactoring. In the branch by abstraction pattern, you determine what functionality is going to be removed, and then you build an abstraction around it. You slide that abstraction into the code and ensure that all of your consuming code is calling that abstraction. Once all of your code is using that abstraction, you can start replacing the implementation. And I'm sure you've all kind of worked with this before. I've seen this multiple times, especially when implementing a repository for data persistence. By abstracting out the CRUDly calls, you can switch in or out databases or even persist through REST services. The last pattern we're going to talk about is change data capture. All of the other patterns that we talked about, both of them, rely on changing and or acting on calls made into a system. Excuse me. I haven't talked this long in probably 3 months. In the change data capture approach, we instead listen for and react to changes in the data. Well, generally a transitive pattern, it's something that you would implement for a while during a conversion. It can also become part of your move to a more domain-driven design approach, especially in systems where there are more than one application using various data tables. For example, the system that I show on the slide uses SQL Server as its data store. That means that you have the ability to have access into the events that are going on, and then you can take advantage of that, and then you can either use triggers to push it or even a completely separate set of code to be able to move that information over to a different data set. And I mentioned earlier that this could be a transitive pattern. Think of it as a way to be able to work in parallel between building the abstraction layer and the alternative system. Once the abstraction layer is completed, you can change the way that the data is being saved into the microservice there, like we show on the screen. Excuse me. So we've talked a little bit about DDD and some of the patterns. Let's set the stage for our demo app that we're going to walk through. And this is important because you need some of that ubiquitous language. Our company is an e-commerce company that sells widgets. These widgets can come in different sizes and colors and can be provided from multiple manufacturers. There are several different sales approaches taken by the business. They sell direct to consumers through the forward-facing section. The company also sells through joint marketplaces like Amazon and a couple others through APIs. And they're all managed with an inventory module of the system. The company also acts as a distributor to other retailers where we provided quantities of product at discounted prices through a B2B marketplace. Basically case quantities at a wholesale discount. And there are multiple other modules within this big old monolith that are being used throughout the enterprise. An internal module that purchasing and receiving departments use to manage purchase orders. They would define inventory with that as well. Model that supported order fulfillment and things like pick lists and the capturing of shipping information. Module that's used just for inventory audit. Lots of different modules that are broken up here, but they're all talking to the same database. So a really rough system diagram looks like this. A centralized data store that stores all of the transactional data across all of these systems. In this case, there's a layer of web services that handle all of the work necessary within the error. And notice that I didn't say domain, though I may have in a more casual conversation. There's also a lot more services than these, of course. These are just some of the more obvious ones that I wanted to talk about. On the right side is the bunch of the servers, the load balanced big old web app. So if we look at some of the communications that are going on, you'll see that the big old web app calls a lot of these services, but there's also a large amount of service-to-service call going on as well. So imagine how scary it would be to try to figure out how to add some new functionality into the purchasing module, for example. How do you wedge that into the other rules? With the current design approach, anything you do for one module can potentially affect other modules. What this diagram also shows is how business rules tend to get scattered amongst different areas of the system. In this case, there's some orchestration going on in the big old web app as it determines what services to call when and with what data. And, sorry, did that message? And there's other things that are going on with the big old web app, decisions being made around processing the order and things like that. So if the orchestration or management is not done in the big old web app, then it's most likely done in the order service, which would account for some of that intercommunication. Is this the best way to do this? Probably not. So let's continue and look at the database design. This slide shows a list of some of the tables on the left. So a list of some of the tables on the left and the partial rendition of the database diagram on the right. What does this show? Well, first of all, that there's a single database that contains all of the information for the company. Second is that there's some separation of concern because there are schemas that are being used, purchasing, products, and website, and orders. See that little yellow box? It's the most used table in the system, the users table. It has lots of foreign key references to it because of the created by column that is present on a lot of the tables. However, there's also relationships that don't have foreign key definitions. Let's look closer at the orders and order details area, that area of the three tables in green. The order details has only one foreign key in it, and that's to the orders table. There are no foreign keys to the product table or the size table or the color table or any of the other tables where you may expect to have some kind of a database relationship. You know, the reasons for this decision was lost in time, but I would imagine it probably had something to do with a refactor or redesign somewhere along the way, which meant that that historical orders would not be able to support the foreign key relationship to it. So they just didn't add it. And there's a lot of these little code smells all throughout the application. And to be honest, in every other application that I've ever worked on that's had a lifespan of more than just a couple of years. So don't judge it too harshly. There are a few things that are going on here, much of which is done serially because in the current approach, you cannot create the next one in line without the ID from the earlier step. Thus, you can't create the customer during the order process without already having a user. You can't save the order unless it has the payment ID. So that has to be saved first. However, we weren't complete morons when we built this original service layer. So some of this orchestration is done in a way that supports reuse. Let's take a look at which of areas of the system is doing this process. So there are really two serial processes going on. This slide shows the order in which they go and what service has the responsibility of running them. The first is on the website as it builds out the required information, namely the user, customer, and payment, and then sends that to the order service. The website then empties out the shopping cart. Once the call gets to the order service, it turns around and calls the product service to update the inventory and calls the communication service to send the order confirmation email. So to support the 7 steps in the order flow, the communication flow looks something like this. Other business flows are very similar. In some of them, the website does some orchestration and then hands it off to a service. The service generally handles the persistence and then performs additional processing based upon whatever business rules were defined for that service. So this is what we're going to refactor. So how do we even start to fix this? First, let's define the rules that we're going to work under. The first, and this rule should be very obvious, is to take an incremental approach. Do not try and deliver everything at once. In fact, incrementing both horizontally and vertically is okay. The most important consideration is that you make continuous progress. The next rule, and probably even more obvious than the last one, is that you must continue to support the old way of doing things. Since there's so much interaction between services, it's likely that there'll be things going on that are either missed, unknown, or you just haven't had a chance to get to yet. Hopefully just the last one. Next is to make smart technology decisions as you go through it. I know some of you are kind of giving me that look, but I've seen a tendency to think small when looking at these decisions. Quotes like, just enough to get by now, or I'll add that later, are very agile-like, but will also end you up with more tech debt than you already have. Remember to plan for tomorrow's work, next quarter's work, and next year's work, and make the best technology decision as possible. Now, this doesn't mean that all these decisions have to be implemented now. What this means is that they need to be accounted and planned for. It's perfectly okay to say that I want to move this order service away from SQL Server to a NoSQL database so I can more easily support future changes, and not do that work until you want to do those future changes. But make that decision as early as possible and make your design and architectural decisions around that end goal and how you plan to get there. The next is don't be afraid to change the way things are done. that you historically did all of your data access through stored procedures does not mean that you have to do that moving forward. Instead, take the time to evaluate your current implementation approach against your end goal. Some of what you've done could just be picked up and moved. Other existing approaches or designs may simply need to be scrapped and redone. You should never put yourself into a place where this is how we've always done it becomes an acceptable answer. Yep, definitely way more talking than I'm used to. Lastly, and I'm kind of harping on it again, but build that ubiquitous language cooperatively across all of the teams. Agree on the language and stick to it. Change the language as needed, but do it together. Even if everything else turns into a big old smelly bag of nope, having the language in itself will make the whole effort seem more worthwhile. Even if you're just using it when you're yelling at each other in your retrospective, because at least you'll be speaking the same language. These rules should be kept in the back of your mind when you start determining the strategies for your refactor. So one of the easiest ways to start building your ubiquitous language is to build your context in bounded contexts. In this case, we're going to define the context as the website and its supporting functionality. So everything. The bounded contexts then become the different business areas or domains. Many of you have probably considered domains before, so remember that a bounded context is basically a domain. In this case, we've listed product, customer, purchasing, order, and geography, though we know there are many others. When you evaluate your own context, try to stay away from reinforcing the constructs that your system already has. Step back and actually evaluate the context. Remember, one of the key points for this is building your ubiquitous language. Define and describe what needs to go on to support the business, and don't be afraid to redefine terminology as you go through. In many ways, that may make it easier. Let's say you currently have a quote service that performs a series of actions. If you determine that the things that the service cares about is correct, then perhaps you can call it a quote in the new system because it implies the same responsibilities. If, however, you need to change the behavior, then I recommend that you rename it in your ubiquitous language to something else, estimate or something like that, because that'll help you describe the new sets of behaviors and responsibilities and will delineate that it's different from the previous thing, the quote that you used to have. And also, by definition, a monolithic application, which is really what this is, even though it's a series of a big web app and a series of services, has some domain creep. Because let's say your quote will know which order number it was used for. Now is your time to fix this. You'll see that even visualizing using a bounded context approach is a different way to look at your business. It seems less rigid. Maybe it's because the lines are dotted. But it also makes you look at the responsibilities of the bounded context as a whole and not necessarily as its part within a distributed system. Once you have some idea around your bounded contexts, the next thing is to define the communication between the different bounded contexts. With the subset shown on the slide, we know that the purchasing bounding context has to get information from the product bounded context. I'm going to stop saying bounded context. So the customer gets information from the order and geography. Order gets information from customer and product. Why? Because it makes sense to have a relationship between them. What does purchasing do if it doesn't relate to products? Or what are products without, or what are orders without products? And as you build out these communication streams, pay attention to these three important details about these communications. What each of these contexts need to know, why they need to know it, and when they need to know that. Because understanding those key bits will help us design our system. So I pulled out the communications between the product and purchasing. I use this as the example because of how it shows how domains can be different for different companies. The way that this company defines their business is that the product is the most important thing. Then they'll find out the best place to get the product some later. Many other places have a different approach where the purchasing domain actually provides the product to the product domain. In that kind of business model, the defined product would be created as part of the purchasing set of functionality. In this one, the product bounded context manages the actual ownership and creation of a product. It then lets the purchasing bounded context know when something's changed, which is all it really needs to know for this business and the way that it runs it. And so here's how this relationship is currently defined in the database. The half with the gold is the purchasing schema. The white side is the product schema. There's a single foreign key relationship from the purchase order details table in the purchasing schema to the product table in the product schema. If you take a look at the product table, you'll see that it has, or the product, table, you'll see that it has 3 tables directly related to it, with a couple of those related to other tables. This means that a fully instantiated object graph of a product could be pretty gnarly. And it's hard to imagine that the purchasing system actually needs all of that information. And it doesn't. So while it does need a few more pieces of information than I show here, it's only a small fraction of the overall object graph, basically so that the purchasing agent can fill out a purchase order. But it's been identified. That's what the context needs and why it needs it. The last question is when. In this case, does the purchasing context need strong consistency or does eventual consistency work? What kind of lag between can your system tolerate between the product context knows about the new changed product and when the purchasing context knows? The more tolerance you have, the more eventual consistency is appropriate. So back to how to plan your refactor. We talked about describing context and defining communications, what, why, when. The next step is determining the most critical core area of your application and define that in detail. So if you remember back to the earlier slide on DDD, it used the phrase, a way of focusing on core areas for design considerations, something like that. This is what you do now. Determine those core areas. Some of this will be at the infrastructure level, such as defining, sending, and receiving messages to and from the message queue. Others will be more domain level. And as you go into your refactor, there are a couple of items that you have to do as part of your planning process. The first and most important is to define your critical area. This most likely includes several bounded contexts. This could also be spread across multiple systems. Once you define those critical areas, define the communications needed between each part, and then start breaking the chain. Remember this process that we talked about earlier with the communication schema that looked like this? Would an approach like this make more sense? Assuming that eventual consistency is okay with the business needs, this could mean solving the problem like this. The user website places an order. The website bounded context saves relevant information about that order. It then sends an order placed message. Orders and products are both listening for that order placed message. The order takes that message, saves all of the information locally, and does whatever business activities need to happen. The product also takes that message, but all it cares about is the product ID and quantity that was ordered. The product subdomain takes that information to decrement its quantity of available product. And if evolution of the business means that some other subdomain is identified and added to the ubiquitous language, and that ubiquitous language characteristic cares about an order being placed, then you just add that in as well. And you don't affect any of the already existing code. None of that has to be changed. So rolling in that new functionality is almost as low risk as it can be. Unlike what you would do if you're going to make the changes in the current version, say adding a new step into the process that the website has to perform. And since the change is happening on the website, it has the potential of affecting all of the other steps of the process that happens on the website. So the risk of that change is much higher than using the new design. We know that the website calls multiple services as part of its processing, including order, user, and payment. So let's talk about how those two highlighted systems and how they should change. So this is what our goal system looks like. The website will pass information along to a website service, a new service. The website service will persist that information that the website thinks is relevant and then queue up a message containing that data. The order service, rather than being directly called by the big old web app, is now listening to the message queue for messages that fit the appropriate criteria. So we're adding two new constructs here, the website service and its attached storage, in this case, Amazon Aurora, wonder how that happened, and the message queue. And we're changing the big old web application by removing all of the business processing that it was doing and moving that processing to the new website service. So we're changing the order service so that it listens to the message queue for an order created message. So this is the work that needs to be done. Refactor website to remove business processing, create new website service to website domain work, and refactor the order service to listen to the message queue. So this is pretty much what the website looks like now. There's a bunch of client side logic. There's the controller layer that accepts user input and returns the UI elements. There's a business logic layer that does all the processing and orchestration. And that's what we're gonna have to move. Ideally, a lot of this would be easy to move because we have some kind of an abstraction layer already between the controller and the business logic. If you do, then it's pretty easy just to replace the current implementation with a layer that calls the website where this business logic will be moved to. In this case, however, we needed to add that abstraction layer between the controllers and the business logic. And once you get that done and have verified that all the communications between the controller and business logic pass through that abstraction layer, you could then refactor the previous business layer to call the new website service instead. So right about now, you may be questioning my decision to create a new website service. In my mind, one of the most common mistakes that developers do when moving to a microservices-based approach is to perform any business logic in the website itself, because that's really the UI here. Even though traditional ASP.NET development supports a lot of business logic in there, it's not the appropriate place for it in a fully distributed application. Let's break that apart. Instead, let's add that abstraction. The new layer provides scaling. If the business logic processing is expensive and the UI rendering is not, then you could scale them differently. You have more flexibility about being able to scale part of your app rather than the whole thing. Also, by making it its own microservice, you now have the ability to pull out and persist some of that information that was leaking into other bounded contexts. Things like a shopping cart or visitor tracking and other things that the website cares about, but none of the other subdomains really do. Making this change decreases your risk of changes to the system moving forward as well, because you're decoupling it. You're decoupling the presentation and business logic so that each can be managed on their own. So this is a higher level view of the current order service. It's pretty straightforward. There's a defined API that includes the endpoints called from the website. There's the business logic and then the persistence layer. When you consider this design, what kind of changes do you envision that you'd have to make for it? Let's take a look at one approach. So this is an idea of what the order service would need to look like afterwards. First, we would need to add a message handler. This is going to pay attention to the message queue and react to the various messages that come through the order service that it cares about. And then, because the order service itself is going to be doing a lot less work, since it won't need to care about things like who fulfilled the order and other details that properly belong in a different subdomain or bounded context, we'll need to refactor that as well. We'll need to add in a messaging layer to process outbound messages if the service is going to send any. And then we'll redo the persistence layer because we're no longer going to be saving information in the shared database. And our model is able to change because it only has to track the things it cares about. And lastly, we'll need to refactor the business logic layer because of all the changes that are going on. We're removing a lot of responsibility from the service because it doesn't belong in this bounded context. Traditionally, what you've seen is these kinds of models are based off of an order, and everything that has to do with an order ends up going through an order service, even though they're maybe coming from different parts of the business and different aspects of the business. So those will end up becoming the responsibilities of those appropriate subdomains. That means, and I've seen it every time I've done this, that you'll end up with more individual services, but the responsibilities for each service and the boundaries around each will be much more clear. This also means that it becomes much more clear whether or not a particular subdomain cares about a particular piece of information. And if you remember this slide, you'll see that the order service did the processing to update the product inventory and to send the order confirmation email. But it doesn't have to do that anymore because those services will already know about it, because they're smart that way and because you've made the same types of changes to them. So this work seems intimidating. There are a lot of changes to go through. It'll be frustrating. It'll take you way longer than what you expect. However, it's very doable. I've done this several times myself. As long as you concentrate on understanding your domain and building your ubiquitous language, differentiating your bounded contexts become clear. And in my mind and in my experience, that's always been the hardest part, especially for existing applications. Defining the communication between those bounded contexts as well as the business rules within the bounded context, they help you understand the appropriateness of specific implementation approaches such as CQRS, messaging, and eventual consistency within an individual bounded context. After understanding all of that, writing code is almost just an implementation detail. So I know we try to cover a lot of things in a short period. I appreciate your sticking with me, especially as I choked up a couple of times. And especially since we didn't get as deep into the weeds as I imagined some of you were hoping. Any questions?
Feel free to put questions in chat, or if you're on the Zoom call, you can.
And if you're interested in anything that's going on with .NET on AWS, there's our Twitter, handle at .NET on AWS. That's where we'll talk about the new products that we're doing, the work that we're doing, supporting the .NET Foundation and things like this. Yeah, I will send the slides over to Steve and Will to make sure that they have them.
I have a question for you, Bill.
Yeah.
We're well down this road of what you've described, of breaking down a monolith and building bounded contexts. One of the things that I question and struggle with, I believe, and I just want to clarify what you said here so that I feel like I'm on the right track. But when you define a particular thing in your domain, a user, a plan, whatever you want to call it, it seems to me that your recommendation is that you carry that language across the different bounded contexts and maintain that. Is that what you're saying? We're facing an issue where we don't own the concept of a plan, but we have to interact with it and we have to maintain some data and state within our BC that is plan related. And I just want to make sure I get the naming and the conceptual model correct.
Yeah, and that's, and I'm glad you asked that question, because that brings up a pretty common, almost what I would say I don't know if I want to call it a misconception, but an interpretation where a user is a user is a user. And I would say, I would instead recommend that a user defines the same thing, but it defines it differently for each one of the bounded contexts. So a user is the person that's interacting with the system, perhaps. So the authentication system has a whole different concern about that user than what the order system would have, because it doesn't care whether it's authenticated. The order system doesn't even care about what the address is or anything like that. It just cares about the list of products and some other ancillary data that it's going to send to other parts of it. So I think the ubiquitous language would define the user as being the same thing, but what each one of your bounded contexts cares about that could be completely different.
Yeah, and so the recommendation is to still call it a user, but
Yes.
you think about it differently.
Yes.
And
Yep.
That makes sense. Okay.
Well,
thank you very much.
I would say you still think about it the same way. Well, I guess, yeah, you think about it the
Sure,
same way, just
maybe.
differently.
Right. Yeah. Same but different. Yeah. Yeah. We care about different things about
Yep,
the user.
yep.
And we think about them in maybe a slightly different way, but
Yep.
it's still, but my point is it's still a user and we would still call it that.
Right.
Okay. Thank
Yep.
you.
So let's see. There's a comment in the chat about the doubting that the approach is successful because you lose transaction control. There are actually some patterns that emulate transactions. Epic pattern is one of them, where it's basically an expectation that a series of messages will be run, and if the series of messages aren't completely run, then the transaction isn't completed. So it's not a transaction that you would think of in a database format, but it is a transactional approach that you could do to do rollbacks of data or fixed data and things like that. Ideally, a transaction becomes pointless because each individual business concern only cares and makes sure that it's being successful. And then as you implement out your systems, that's where you're going to put things in like dead letter queues and stuff like that, where if a message is failed to get processed, which sounds like the only problem that you would have for losing the transaction control, you would be able to replay that and correct that error. So hopefully I answered that.
You yourself have built things like this that were successful, right?
Yes, I've only been at AWS for about 1.5 years now, and before that I had a real job as a real developer.
Yeah, this isn't the first time I've heard about this approach, so the comment from YouTube, I don't agree with. We have
There were a couple other questions, right? Oh, sorry.
Yeah, just gonna go to those other questions in the Zoom chat.
So
go ahead.
Is a bound to context the same as a subsystem? I guess I'm not sure how subsystem is being defined there. In many ways, they could be the same, but I don't think I'm giving a very good answer to that.
Yeah, there was another question above that about storing the code. How you store the code for each microservice or bounded context.
Wow. Yeah, you know, that's interesting. I've seen it 2 different ways. I've seen it where every microservice has its own repo, and then that repo would be just deployed out on its own in its own time frame. I've also seen it where it was all part of a single repo where each microservice just ended up being for lack of a better term, a directory within the major repo, and then it would just still be built out and deployed at its own time. That's almost more of just a convenience in the way that it fits in. I don't know that it really matters on that. I guess it would come out to the same thing about how you branch your code and what and how your system manages branching, and whether it duplicates the entire thing across it or just the directory or things like that is where I think will probably drive how you'd want to break that out instead.
Yeah, I can add to that. I've seen it mostly done with repos for, a repo per service.
Yeah.
And I've heard big companies like Google, they call it mono repo approach, yep. Which they can afford to do because they have developers that can write a bunch of tools. So that's just my experience. And then we've got Wes wants to ask a question verbally.
Yeah, thanks, Steve. Hey, Bill, thank you for the presentation.
Hey.
I've got a question for you on some of the things you presented. On one of the slides, or a few of them, you talked about how the website front end should be split apart from the back end to be able to allow for independent scaling. And I think that's all fine and good. For us, we think about a bounded context as a collection of multiple microservices. And so that allows for like front end and back end scaling as well independently. But in your example, it appeared that you were advocating for splitting those into separate bounded contexts. So can you clarify that? How do you think about that? How do you approach that?
Yeah, that's a good question. I would say it really depends. There are definitely times where I've seen bounded context broken across multiple microservices, and it really comes down to what's going on and how each of them may scale. The biggest thing is if there's something where there's especially like IoT type apps or something like that, where there's just data churning through. It may be part of the same bounded context as other calls, but you want to separate it into its own microservice just so you can scale it out separately. I think that's one of the cases where where I see bounded context going across multiple services. Now, the problem that I actually had with this website was that there were, I would say, probably a third of the business logic was actually being performed in the business logic layer of the website itself. So the separation that we did was to take that out of it. It could easily have been into something that was, directly fed into the messaging, and we kind of talked about that. But there was also enough other information that this seemed to be the only place that we cared about it, that we decided to call it its own bounded context, and that's where we would track things like viewers and usage and some of the data around how people were interacting with the site, like mouse movement and stuff like that, would all be stored in this same area. So for us, it was because the work that we were doing in that bounded context was really tied to the website and some of the information going on there. And then it just became part of a way to kind of, the website would come in and do that and put it out. And then we also made that decision because we had another client application that we were making the same sorts of changes for, and we had a different set of information that it cared about. So it ended up having its own, I don't want to call it that, but it was almost like a desktop bounded context to manage all of that kind of information deployed out in a microservice. So I don't know if that answered your question, but I kind of gave a little bit more detail as to the approach that we took when we broke out that section from the website.
Yeah, thanks for the detail.
Okay, we got one more question in the Zoom chat that I think that'll be our last question, and then we'll move on to prizes. By the way, in the Zoom chat, there's a link. If you want to be eligible for a prize, you click that link to fill out a survey that you can rate the presenter, and we'll give that feedback to Bill. So the last question is, let's see, why do microservice projects fail? The project, not the system.
I would say the most common time that I've seen people throw their hands up in disgust and walk away is because they haven't done a good job of building the bounded context. I've never really heard of a microservice project fail because of technology. I've heard of it fail because of the approaches that they were taken to define the relationships that it would have with other parts of the business. That's where if you falsely identify your domains and your subdomains, there's no way that you're ever going to be able to get them working right without starting to slide business logic across those bounded contexts. Or conversely, you start adding more and more new bounded contexts that don't really map to some part of the business, but instead become just some kind of an artificial constraint to try to work around and patch together the things that you've already put in there. So that's why I kind of pressed on ubiquitous language and why this this session doesn't go into the technology at all, because it's really the planning and the pre-architecture and the pre-design that I think is what's going to make it successful or not. And I just put over a new thing. We've got a 2-day workshop going on in May where we actually take these things and we go down into the code and we actually make these changes in an application. So if you're interested in seeing what this would look like a little bit deeper, go ahead and I'd recommend sign up for that. I think it's a $50 workshop for the two days.
Okay, thanks. I'm going to share my screen. So here's the link. If you didn't get the link in the Zoom chat, here's another way to get to that link.
I'm going to go ahead and stop the stream now, I think, yeah?
Yep.
To YouTube. All right. Thank you, everybody on YouTube, for joining us today. You're awesome. We appreciate your comments and thoughts and watching and like and subscribe and all that good stuff.